Alright, I said that I will not do any more videos on the GPU SDL thing, but I was actually tinkering some more with that because I wanted to implement some lighting and stuff, and I also wanted to do some cleanup and some multi-platform support. And one thing that was mentioned in the comments by Mole Wizard is that actually SDL Shadercross, which is a Shadercross compiler by SDL themselves, is actually available, and you don't have to go through pain of building it yourself, because it is actually available on their GitHub. If you go into actions, and for each build, just select the latest build from the main branch, and here you can actually see the artifacts, which is a binaries for all the systems of the Shadercross and SDL and all the dependencies, everything that you will actually need to use the SDL Shadercross. So you don't actually have to build it yourself, and you can just download and use it. And that's why I also wanted to make use of it, and maybe also port shaders to HLSL, because it's supposedly more fancy, and also because this is a source format for Shadercross that you can directly input, because it only supports HLSL or SPIR-V, but SPIR-V is a binary format to which you need to compile, so it's easier to just write HLSL and compile to SPIR-V, Metal, or DirectX bytecode. So this is what we are gonna do, and with our current system we have to actually do this in multiple steps, because our current project is already kind of messy. So what I want to do is, first, instead of embedding the bytecode for the shader, I actually want to load it from the file system, and also maybe have some convention to actually detect whether it's fragment or vertex shader from the file name, stuff like that. So let's maybe do that. What we are gonna do is actually rename this SPV frag and SPV vert. So for the convention, I want to have first the shader name, then whether it's frag or vert, like a first extension, and then the second extension would be the file format. So I actually want to swap SPV and frag here. So this is what I'm gonna do here first, right? Maybe let's comment out the shader compilation for now, because we will change it to something else anyway. So let's do that, so it gets out of the way. Let's see if our game still works. Yes, it does. Alright, so what we are gonna do is just delete this stuff, right? And if we do this, we will of course get our errors, our undeclared variables here. So instead of the bytecode itself, what we want to pass is just a file name for the shader, right? So this is what we are gonna do. Let's say that is gonna be shader dot vert, and we are gonna pass just a base name without the actual extension, because in future we want to select the implementation based on the shader format that the platform supports. So let's just have shader vert and shader frag, right? And then we make the load shader function actually load the proper file. So let's do exactly that. Let's go here, and what do we do here? Here we have the code, which is just an array of bytes, right? And this is what we want to change. So let's say that would be a file name, or maybe it's not even a file name, it's shader file or something, which is a string, right? And also because now if we take a look here, we pass vert or frag, what we can do is basically just guess whether it's vertex or fragment from this extension. So let's just remove this stuff, right, like this, and go back, and now delete the stage argument, something like this. And what we want to do, well, first we want to of course get the extension from the file name, and for that we can actually use an Odin library called file path. So if we import it from here, there is a nice core package called path/file path, this one. Now if we go back, we can say give me an extension, or actually we're gonna switch on the extension of the shader file. So we say file path ext, right, the extension, and there's also a long extension, but what we want is just the last extension, and this is the ext function. And we say shader file, right, and here we check basically if it's a vert, then, well, the stage will be vertex, right? Otherwise, if it's fragment, the stage is fragment, right? And don't forget to add the stage variable, of course, stage SDL GPU shader stage. So now we need to get the code. So stage is here, we just need to get the code. And for that we need to load the file, of course, and this is done by using the core OS package. So let's just import it core OS, something like this. Similarly, how we do it in OBJ, if you remember, we do it here, core OS, and we read the entire file from the file name. So this is what we're gonna do for shader loading as well. So basically we say, alright, code is OS read entire file from file name, right? And that basically returns our data, our byte array, and whether it was successful or not. So this is what we're gonna do, except that remember that the shader file is the base file, excluding the actual format extension like SPV for SPRV, or later we will have, of course, metal or DXEL or something else. So we need to actually construct this. For now we are continuing to use SPV, so we need to construct a file name with a SPV extension. For that we can simply use the strings package to concatenate the extension to the file name. You see, it's actually already imported. So let's go back and say, alright, file name will be strings concatenate shader file, and we just add the SPV part here, right? So this is what we are using for OS call. And for allocator, we can use the temporary allocator. Remember that we are freeing it every frame, so it will be freed as soon as the game is running, so that should be fine. This allows us not to care about memory too much, because this is temporary anyway. And we just do context temp allocator, right? And as for tradition, we can just assert that it was okay and be done with it. Right, this is actually not a variable argument function, it's actually a function that takes an array of stuff, or rather slice of stuff. So we just wrap that into a slice syntax. Now we just rename our compiled fragment and vertex shaders. And hopefully that works. Yeah, that still works. So this is a good first step. Now, because we're gonna introduce some more shaders, because we're gonna compile shaders for different shader formats, it's probably a good idea to clean up this mess a little bit into folders. So let's maybe move at least the Odin files into some SRC directory or something, right? Now we need to adjust the build file for that. So instead of the current directory, that would be SRC. Hopefully it still works. Yes, it does. Okay. Now the textures and object files and shaders, those are supposed to be content. So maybe create a content folder. Inside of it, let's create a textures folder. Maybe meshes as well. And then also shaders. And inside shaders there will be source shaders and the out shaders, the ones that we are gonna compile, right? So let's move the textures to textures. Let's move the meshes to, of course, meshes. Just here. Now let's move our source shaders to the source folder and the compiled shaders to the out folder. So far so good. Let's update our code to look into those folders, of course. So let's maybe introduce a constant for our root content folder, something like content dir. It would be just content, right? Then if you go to the load model function here, so it expects a mesh file and texture file, right? So we can maybe change that to mesh path and file path and add our folder prefixes. So mesh path would be simply file path join, another function from the standard library that takes a list of path elements. That would be our content dir, then the meshes, right, and then the mesh file, this one, right? And we do the same for the texture path. So texture path, file path, that would be of course textures, and that would be texture file. So now the texture file here, that is just conversion to C string, that should take a texture path. And finally, when we load the mesh file, that also should take a mesh path. Right, the next thing is of course loading of the shader side. So load shader one, this one here, so that currently just concatenates the shader file with the SPV, but it should also add a folder prefix for us, right? So let's maybe say that the shader file is file path join, that would take content dir, right? Then the shaders out, because that's not a source, and then the shader file. Let's see if that works. Yes, it does. So if we take a look at this file structure, it's much cleaner now. So the content ends at the content, sources are in the sources, much cleaner. Now, before I forget, actually the file path join is an allocating function, and it takes a allocator, and we want to either, of course, free this memory, or we can just pass the temp allocator here as well, which is not the default. Default is the context allocator, so that needs to be manually cleaned, but we can of course pass the context temp allocator here, and in the other usage it's the same, right? So this ones also need to take the temp allocator, right? So here and here. So now we have our foundation to actually use the Shadercross library and compile from one source to multiple different output formats. And assuming that you have installed the Shadercross library and added it to your path, you should have a Shadercross command like this, right? And if we take a look at how it works, is that you just specify the input here, which can be either as per V or HLSL. Remember that SPERV is a bytecode that you produce from like GLSL with GLSL compiler and maybe some other like DXC and whatnot. Or you can just use directly HLSL. So this is what we are gonna use. So we are gonna port our shader code from GLSL to HLSL. Also, that's kind of new for me, so it's a good exercise. Then the destination, also it may be inferred from the file name, so if we specify the correct extension, it will be inferred and we don't need to specify this. The same for shader stage, it can be inferred from the file name like vert, frag and compute. Then the entry point, the default is main, which is totally fine for us, and then the output file is another one that we need to supply if we want this inference to work, and everything else is something that we don't really care right now. So basically we need to say Shadercross input file means O output file, right? So this is what we are gonna use here instead of the GLSL C. And honestly, this batch file is kind of getting annoying because we want to call Shadercross multiple times for different formats, and with batch file it's not really nice. It's just a very annoying language to write on. So let's maybe for now just start with batch file, but then my idea would be to actually just write a simple build script in Odin directly and use it with Odin run command. But this is for later. Now what we want to have is Shadercross, right? Then we have our input. Remember that would be here, right? Shaders, content shaders src, and then the file name. So that would be content shaders src. So shader frag HLSL, right? Minus output content shaders out shader frag SPV. So for now we are still using SPV. This is something that we are gonna use instead of GLSL for fragment, and also of course vertex shader. So here instead of frag we use vert, something like this, right? And yeah, this of course needs to be Shadercross, not Shadercross. And now let's start with simply renaming our GLSL frag and vert sources to HLSL. So that would be frag.HLSL, and of course vert.HLSL. Now if we try to build it and take a look at the output, we will see that we actually get of course the compilation error because it's a different language, not GLSL anymore. So we need to port this from GLSL to HLSL. So let's actually just do that. So how HLSL works is that instead of uniform you specify something called constant buffers, and for the layout, for the input and output, you specify just input and output structure parameters. So yeah, this is what we are gonna do. We use a C buffer. The name would be the same, UBO. Then instead of mat4, we use float 4x4. Then if we take a look at the SDL3 GPU shader documentation here, it will say that for DXEL, which is basically, well, HLSL, it says that it needs to specify this format for uniform buffers, right, for vertex shaders and pixel shaders. So basically this corresponds to this resource sets. You need to specify where we specify the set 1, that needs to be a space 1, where we need to specify set 2, that would be a space 2, and so on, right? So, and the syntax for that is just that we say here register, that would be buffer 0 and space 1, kind of similar to this one, right? So this is done. Now this one needs to be changed to a structure, so let's maybe say struct, name it input, now all this stuff can go, right? Instead of vec3 we use float3, so float3, the same float4, and the same float2, right? That would be our input, and we do the same exact thing for the outputs. So struct output, so that would go here, of course, and we can just add float here, and we can actually get rid of the out prefixes here. And how it works now is that the main function actually takes an input, so something like this, like a normal argument input, and it returns the output. So basically like a C function. Let's create an output local variable, right? Output out, something like this, right? And then we can just replace this one with this one. And instead of GL position, what we need to use is an additional output field with something called semantic value, which is an additional HLSL descriptor syntax that is added to the fields, right? And this is what we are gonna use. So we need to return a float for position that we want to output, and then semantics for that would be SV position. That would be the specific one that is needs to be named like that. Now instead of vec4 we also use float4 constructor, and instead of the multiplication parameter we would use the mul function. And finally we return the out. And another thing that we need to specify here is the semantics for all the other even non-system value fields of the output, and actually the input. That actually doesn't really matter that much anymore in modern Direct3D. It's actually described here that you see it doesn't matter in Direct3D 12, and for reason of use, SDL implementation assumes that non-system value semantics, so like not non-SV, will be all the text code, which is a special name for originally for texture coordinate, but you can use it actually for everything else. And SDL assumes that the semantics should start with text code 0, increment like so, text code 1, 2, and so on. Not sure how they actually use that, probably for something internal, but what we can just do is say text code 0, right? And then do the same but 1. Now we also need to do basically the same here, right? Text code 0, 1, and this would be 2. Let's see if that compiles. Interestingly, it does return the apparently 0 exit code or something, but still complains and does not compile really. But let's try again after removing that leftover. Yeah, we are getting some more errors here, that the dot operator cannot be used, and some more. Yeah, actually I think the problem is that out is a resort keyword, so let's just change it. That's a bit too much. Now this should be of course input, and the input position. Now let's see if that compiles. Almost there. Yeah, the vertex shader is now compiled. As you can see, there are only problems with the fragment shader, and we can actually take a look that the vertex shader is here. The SPV file generated from HLSL seems to be working fine so far. Now let's go to the fragment shader and port it. So we can remove this one, right? It's the same. Now the output of the vertex shader will be of course the input of the fragment shader, more or less, except that position is something that we don't really care about. So we take the color and UV. That would be of course input. the output is just a single frag color, and what we can do is actually not define the struct type for it and simply output the float4 and specify the system value semantics directly as a specifier for the function, and the system value for this would be sv target 0, so the first output color target. Now for the texture sampling, we actually need to provide both texture and the sampler state here instead of this unified sampler 2D. And how we do this is by using this special texture type, so texture of float4, so 4 component elements, let's just call it text or something, and we need to also specify that it's a texture using the register specifier of HLSL, the texture 0 in the set, or rather space 2, exactly like before we did with the GLSL. And another one is sampler state, let's just call it SMP, register, and that would be S0, so sampler 0 in space 2. So just like in the documentation for SDL. Now here what we just do is return, and how we sample the texture, that would be almost object oriented. We call a method of the texture called sample, and here we specify the sampler state and input UV, right? And then we just multiply it by input color, and don't forget to, of course, add the input argument here like this. Let's see if that works. And it doesn't, because yes, it's not texture, of course, it's actually texture 2D, like this. And now we have 2 perfect HLSL shaders that are compiled using the Shadercross into SPIR-V, and we didn't need to change anything in the Odin source for now. Alright, I think that's enough for this video. We made some cleanup, we improved the shader loading, and we ported the shaders from GLSL to HLSL and set ourselves up for success to actually compile to different shader formats and also maybe use some shader reflection. We'll see how it goes in the next video, so stay tuned.